Hi, welcome back again. In last 3 lessons, we studied the application in the biology field. But now in the next 3 hours, our focus will shift to the geometry and the engineer applications. And today I'm going to show you the linear transformation. This word transformation, you can read trans means change the form, basically. Well, you're going to look about those examples in everyday life. Just to give you one example, if I just shrinking down the window, let me do one thing. See, if I move this around, it's a transformation. Rotate is a transformation. I can rotate it back. And also, if I try to make it smaller or bigger, it's a transformation. Other transformation, for example, if you do robotics, any navigation, you have to transform the coordinate. And like you roll, you yaw, you pitch. In GPS, you have all different coordinates we're going to discuss today anyway. So first, let's just review a few algebra expressions to vectors. The first one we use most frequently. A vector, have a direction and the magnitude. And the first one we call the component form. If you have a 2D vector, like this point, maybe you call it 1, 1. That's what you do in the Cal 3 or Cal 2. And the second form, you can look at the 2 unity vector I here and the J here. That's in your textbook. But you can also call it E1 and the E2. That's just different name. The E1 is the unity vector on the x direction. When I say unity vector, the unity means the length is 1, or say the magnitude is 1. So this is a unity vector. Twice is not a unity vector. And this J also be a unit vector, but have different direction. It's going to be 0, 1. Another expression is, look at this. If this is my x, I can write this x as E1 plus E2. So E1 is 1, 0, E2 is 0, 1. When you add, it's 1, 1. But if I have this be 2, 2, now you just have 2 E1, 2 E2. So that's how you represent it in the projection form. When I say projection, means you see this projected down, that's E1, project this way, that's E2, and by the parallelogram, the law, add this 2 is the diagonal x I have. The third one will be a little bit more strange to you. That tells you exactly a vector have the magnitude and have a direction. Now, just like if you shoot to the bull's eyes, to shoot it right to the middle, need 2 elements. First, you need to have the right direction, of course. That's how you aim it. Second, you need to have enough strength. You don't fall down in the middle. So the magnitude tells you how much strength, force you use. And then the u simply tell you the direction. But the difference is this u must be unit vector. Means the u does not contribute to the magnitude. Give this example again, 2, 2. This vector 2, 2 is not a unit vector. What is the magnitude? It's the hypotenuse here. It's going to be 2 square plus 2 square equals 2 square root of 2. So this vector have the length 2 square root of 2. Now how about this 1, 1? Is this a unit vector? The answer is no. The length is square root of 2. But they share the same direction, right? And then I would like to think out this vector, which I call u. In this case, the u equals the square root of 2 over 2, 1, 1. Or you can write it as square root of 2 over 2, square root of 2 over 2. That's a unit vector. And if you calculate the length, it's 1. So what am I going to do now? Let me call this vector as y. So y equals, let me write into the column. It's going to be 2 square root of 2 times this unit vector. A little bit strange. You say, why I want to make it so complicated? Well, the good thing is when you read this expression, and you clearly know the magnitude is square root of 2 over 2, and this you might instantly connect it to the cosine 45 degree and the sine 45 degree. Are you with me? This is 45. That's a unit vector. Tell you the angle. That's the important part. Well, I'm going to use this right away to look at the projection. If I have a v vector here, that's my v, and I have a x vector here. So what I'm interested in is you think about the light that comes from the top, and then the shadow of this vector will be here along the v direction. So this is the light, and then you look at the shadow will be here. We call it the projection of x vector in the direction of v. It's very long. This is the projection of x in direction v. The question is, how do we calculate? If I know the v and know the x, that's the application of what we learned in the product form. So first, let's get the unit vector and v. The unit vector is the v divided its own length. So let me say this is the unit vector, u. And then I need to figure out the magnitude, the length. Let me call this be the vector p. P. The length of p follow the trigonometry, right? The p divided by the length of x equals this cosine theta. So the adjacent divided by the hypotenuse equal cosine. So this p really equals x times cosine theta. But you say, well, I don't know cosine theta. That's when you learn the dot product. The cosine theta equals the x dot v divided by v and x lengths. See, that's when we defined the dot product is the magnitude the product times cosine theta. So we got everything. We got this p lengths equal this dot product and times the x, and we can cancel out this x, and then that's what we get. It's going to be v over x dot v. That's the magnitude. And the direction is right here. So remember this. We just multiply the magnitude to the unity direction. It's a little bit complicated. So this p is going to be the magnitude multiply the unit direction. Looks terrible? Not too bad. Okay. Let me rewrite. And the v times v, the b angle is 0 equals the v dot v. Just want to write it nice. And then times v. That's the projection. Oh, today we're going to use this a lot. Well, it's terrible, but let me explain it to you. It's pretty simple. This dot product is a number. A number over a number is a number. Nothing else. It's a number. And then this is a vector. A number times a vector like a 2v is just a vector. It's still a vector. Another way to write, I'm going to use is this. If I use the v as v1, v2, we can be v3 if in the 3D, x as x1, x2. Another way to write this is write into a x matrix. Wait a moment. Oh yes, I can do that. That's 2 by 1, and then I can have this v dot v here is a scalar, and then in the middle I can have the v times v prime. I'm going to show you later on. The v prime is this, v1, v2, and the v is this, v1, v2. Look, a 2 by 1 times 1 by 2, what you get? What is the matrix of a 2 by 1 times 1 by 2? 2 by 2, right? That's how you do multiply, and then what you get is v1 squared and v1, v2, and v2, v1, v2 squared. We're going to do an example.